Hi everybody. In this particular lesson, we're going to work on the bubble sort. Now in most languages, we now have a sort function where it's just trained to do this for us. But there's a good chance when you're applying for a programming job, you may be asked to write a bubble sort because the logic is really important and understanding the algorithm can help you in the future. So we're going to go through it. And it gives me a chance to have a duck blowing bubbles. I mean, that's worth the lecture right there. So we're going to go through the bubble sort algorithm, which is probably one of the most standard ways to sort data, either alphabetically, numerically, and you can sort it either ascending or descending. It's pretty much the same logic. So we're going to, in the PowerPoint, go over this, and then we will go through the actual code on implementing a bubble sort in Python, as well as the built-in sort method, which generally is going to get you where you want to go, but I love the bubble sort. It's just such a good algorithm. It's important. You could see it show up on an employment test or an interview, and it helps you understand how to sort of create your own complex functions. So we have a built-in sort method. And so if I were to put in the numbers here, and notice it does allow for duplicates, and I put in numbers as my variable containing a list 31415992, and then I apply numbers.sort, and that will change the value of that variable. It will put the numbers in order inside the variable. There's another command, sorted, which just sorts it temporarily while you're using it. This one is modifying the initial list. It's sorting in the list in place. The sorted function, it copies the list, sort it, and then you store it into a new variable. So again, we've got numbers as a variable with a list. We have sorted numbers equals sorted, and we pass numbers into it. So now we have numbers, which is the same as it was before we started, and then we have sorted numbers, which contains all the same numbers except that they are in order from lowest to highest, and that's the difference between the two functions. So the bubble sort algorithm, you start by initializing a list of numbers, same as using the sorted command. So we have numbers equals, and then we put in 867565309. Almost Jenny. And then we have a flag, which is a indicator if something is true, not true, so that we know if a swap has occurred. So it's our flag. It tells us, and we start it with it being true because we're going to do this with a while loop. So we start, and we're going to continue looping until no swaps occur. So while swapped equals false. So we reset the flag at the start of each iteration. And then we're going to do for I in range, length of numbers minus 1. So it's getting length from numbers, and we're going to do it one less than the time that are there because we're comparing two numbers to each other. That's going to hit all the numbers. And we're going to compare the adjacent numbers, the numbers that are next to each other. And if the numbers I, remember that's your index, is greater than numbers I plus 1, we will say swap equals true, which is saying that a swap is needed, and then we're going to replace numbers I plus 1, and flip the order. If we wanted to sort them in the other order, we would change that greater than sign to a less than sign, and that would change our sort order. And you print the sorted list. So this is our flow chart. So we initialize the list, we set swap to true. And while swapped is true, we're going to set swap to false for I in range length of names. We're going to loop through the names, swapping when we need to until we have checked everything, and then we will end the logic. So here we can do the same thing with names. We have Bob, Carol, Ted, Alice, Anna. Swapped equals true, that's our flag. While swapped equals false, reset the flag. So for I in range length of names minus 1, exactly the same logic, we're getting the length up here. We're going to compare the adjacent elements, and we're going to if if names greater than names I plus 1. So one of the things here you got to watch out for is that they all need to be the same case. First letter capitalized, first letter not capitalized, all caps, all lowercase caps, you need to make sure the same. So you would actually probably use something where we did names dot upper to compare to names. That would allow you to compare, and we don't have to necessarily change them to upper, but while we're comparing them, we need to compare upper to upper or lower to lower. Either way works, just so that we're truly comparing them, because there's a different range of numbers for uppercase versus lowercase, and that can really mess with you. So we do swap the elements, names I plus 1 equals names I, equals names I plus 1, names I. That's just flipping the order. And then we would print out names. So we have a bunch of, oops, that's taking me out of my PowerPoint. So we have a bunch of options for sorting, and we're going to go through those in the next video. We'll play with some of them.